Today we're going to go over how to graph. All right. And we'll start with exponential. And this should be review from Algebra 2. We're going to start with exponential. We've got an equation that looks like f of x equals b to the x. B is the base. We're going to pick key points that are very easy to graph. Okay. I want every single time you to pick key points that are -1, 0, and 1. Now, any more points that you need to draw a graph, that's totally fine. You can pick more points, but these are the minimum points I would like for you to find. So if I have the equation of b to the x and I plug in, let me start at 0. If I plug in 0 for x, what are we going to get? 1 every single time, unless there was some sort of transformation. If I plug in 1 for x, what will I get? Okay. Oh, I'm not on that one. I'm just talking about b. B, the base. And if I plug in -1, what am I going to get? 1 over b, the reciprocal of the base. Okay. So that's basically like our parent function. These will have asymptotes. The asymptote will always be at y equals 0 unless we've got some sort of transformation that would move it off of y equals 0. So let's say we have the function f of x equals 5 to the x. What would the function work? Let's graph that function. Yes, dear.
Go up a little bit.
Yes. Yes.
Okay. Thank you.
Okay, so let's graph 5 to the x, and we're going to start with -1, 0, 1. So if I plug in -1, it will reciprocate 5, 1 over 5. If I plug in 0, always 1. If I plug in 1, the base 5. So -1 1/5 is approximate there. 0, 1, and 1, 5. There is an asymptote at y equals 0. And I'm going to put that in the table under the y side. Let me just graph it a different color, though, because it's not really part of the graph. Now, if we needed more points, I could find more points. I could plug in 2 into my table, but it's 25. It's going to be way off the graph. So this graph is going to exponentially grow. And the other direction, it's going to get closer and closer to the asymptote. And it's already pretty close to the asymptote. So it's just going to basically look like it's going across. But it's not going to pass through it. And we were just talking about a year ago when COVID hit, how when I went to spring break and there were like 7 people that had it. And then now it's just skyrocketed. That's exponential. You know, that's like, I don't even know what the growth factor is. Pretty sure it was like 1 point something when I was looking last year. But, you know, it started out slow and then it just, boom, exploded. That's an exponential graph. So now down here, what would happen if I had 5 to the x plus 3? Transformation-wise, what would that do? It's going to translate it up 3 units. Now, I'm not going to do this for every single one of these, but I want to go through, like, what would I do to the ordered pairs now? I could use the picture itself and take each ordered pair and just move it up 3 full spots. I could use my table and go to the y side and add 3. That's not added. And add 3. There's something else in my table, though. And there's something else that could move up when I add the 3. What else needs to move up in my table? What is it? The asymptote. So if that's y equals 0 and I take the entire graph and I move it up 3, the asymptote's going to go up 3 as well. So y equals 3. So there's the new asymptote, and then the new graph would be there. Transformations. What would h of x equals 5 to the x minus 2 do? Sarah Nold, what would it do?
Move it down to.
Translate down 2 units. All right, harder one. 5 to the x plus 5. So this time the plus 5 is inside of the exponent. If it's inside of the exponent, if it's part of the exponent, it's part of the exponential function. Caitlin, do you know what is going to happen to that? Okay. Well, we've already taken care of moving up and moving down. So what is left? I just gave you a pun. No, it's not stretching. Marie?
It's going to go left 5.
It's going to move to the left 5. So anything that's adding or subtracting is up, down, left, right, depending where that is in the equation. If it's in the actual function, if it's in the exponent, that's going to be left or right. That's the horizontal. Why, Marie, is this one to the left when it says plus 5 there?
It's like how when we're doing like the square thing, it has to be like I'm not good at words.
Opposite.
Yeah.
Yeah. Anything horizontal is the opposite operation. So where it says plus 5, we are actually going to subtract 5. So if I were using this original table here, and don't look at the pink, because that was a different question. I would, on this side, subtract 5. I would get negative 6, negative 5, negative 4. Come over here and I'd graph negative 6 a fifth, negative 5, 1, negative 4, 5. And what would I do to the asymptote when I subtracted 5 from the axis? We don't change it. So this asymptote is a horizontal line. And if I take that horizontal line and I move that line 5 units, well, a line goes on forever. So moving it 5 units to the left is still a line. Okay, so that actually doesn't change the asymptote, which is why I put the asymptote in the y column, so I know not to change it when I do stuff to the x. So that one would be here, and it would have that same y equals 0 asymptote. All right, I'm not going to graph all of these. I just wanted to graph a few of them just so you can see it. So this next one, translate. Chris, can you tell me what happens? Translate what? Correct. Right, 8 units. All right, the next one. This one has a negative 5 to the x. Is the x on the negative sign? Is the x on the negative sign? It is not. It's only on the x. This would be like negative 1 multiplied by 5 to the x. Okay? So the negative 1 is not part of the actual function. It's on the outside of the function. Do you guys remember what a negative 1 does to the function? Anthony, do you remember what the negative, what's it do?
It reflects it.
It reflects it. So we have to figure out which reflection this is. So we need to figure out, is it a horizontal or a vertical reflection? It is a vertical reflection because it's not in the exponent. It's on the outside of the function. And so remember earlier in the year, I pulled out a something to reflect vertically. I'm reflecting vertically. You guys can see it, but the video can't. What axis am I reflecting in? This is the x-axis. And so if we have the exponent being negative, that's going to be reflect in the y. And that would be a horizontal reflection if it's a reflect in the y-axis. All right. Last class, we learned how to find an inverse function. So I'll just use the one that we just had up there. Y equals, actually, let me pick one of these. Let's do g of x. So let's review from last class how we find an inverse function. The first step that we need to do is switch x and y. And I don't have a y, so I'll go ahead and put a y in there. So I'll switch x and y, and I will get x equals 5 to the y plus 3. So what's our second step? Anybody remember our second step? Caleb, do you remember our second step after we switch x and y? So what can I say generally, though? Yes, I'm going to subtract 3. That is correct. But just for all equations. Solve for y. Isolate the y sounds even better. I just don't have that great of vocabulary. Solve for y, and then occasionally we might need to write it back in function notation. Okay. So now Caleb told me to go ahead and subtract that 3, so go ahead and do that. And then what you should be thinking now is you should be thinking that I need to get y, and y is in an exponent. Right now, this is exponential. And what is the inverse, Lena? What is the inverse of exponential? Did you say square root? No. What is the inverse of all exponentials? What are we studying right now? Logs. Logarithms undo exponentials. So if you see the exponent, then we need to use logarithms. If you see logarithms, then we need to exponentiate, okay? So here we're going to log both sides. What base should we use? 5. Thank you. I was going to call on somebody, but you were fast. Who was that? You were fast. Good. Log base 5. Okay, so we're going to log both sides, and that cancels out the 5 to the y. We learned a property last class that brings that in front, even though we were doing it already. And I get y equals log base 5 of x minus 3. And then this was in function notation, so we will write it back in function notation. G inverse x equals log base 5 of x minus 3. Okay, so that's what we were doing last class. Today we're going to graph these. All right, but the graphing part is easier than you may think. This is the one I graphed above, right? I'm sorry, this one I graphed above, right? Yeah. So that equation, not equation, those ordered pairs, I'm just going to copy those ordered pairs. That was, x was negative 1, 0, 1. And then it was 3 1/5, 3, and then 8, and then y equals 3. So that was the g of x equation. Does anybody remember anything about inverses when it comes to the ordered pairs? You remember, Connor? Mm-hmm. So the ordered pairs that I'm going to graph for the inverse are going to be 3 1/5, -1, 3 0, 8 1, and then I have to flip one more thing. Do you think you know, Chris?
Yes.
So how am I going to change y equals 3 to the other column? What do you think? X equals 3. Exactly. So when we go to graph logarithms, as long as you can graph exponentials, which we'll practice some more today, all you have to do is flip them to graph the logarithms. Okay? So let's go through the process. What? What did I put? Oh, I did. Yeah, it's 0. So is that 4? Sorry about that. I still wrote a 0. I really want to write that 0. Thank you. Did I do it correct up here or did I do it wrong up here? Oh, I did it correct up there. I just wasn't thinking. Thank you. Okay, so logarithmic graphs. If we have a logarithmic graph or a logarithmic function, our base is b. The key points are going to be backwards of what they were for the exponential. So I'm going to put my -1 here. I'm going to put my 0 here, and I'm going to put my 1 here. So my first one will be 1 over b. My second one is going to be 1, and my third one will be b. So it's just backwards of what it was for the exponential. The equation of the asymptote will be x equals 0 until we have transformations. So here's that f of x equals log base 5x. So I had just written that one above. I don't want to mess it up this time. So -1, 0, 1, and 3 1/5, 4, and 8. Nope, that was after we did stuff. 1/5, 1, 5. So that would be the just parent function log base 5 of x. So I'm going to graph 1/5, -1, 1, 0, 5, 1. And then I have an asymptote at x equals 0, which is vertical instead of horizontal. So there's the logarithm graph. Excuse me. So for this first one with the transformation, if I have a +3 and it's outside the logarithm, I can tell it's outside the logarithm because if it was inside the logarithm, there would have to be a parenthesis here. So I can tell it's outside the logarithm. What's that +3 going to do to the logarithm? It's going to go up 3, translate up 3. So that means log base 5 of x minus 2 translate down 2. I'll graph the second one because I wrote that one in blue. So if I'm going to translate down blue, I'm going to do down 2. I'm going to still go to the y side and minus 2. It's negative 3, negative 2, negative 1. So I'm going to take each of these points and go down 2. Does that change the asymptote if I go down 2? If the asymptote's vertical and I go down 2, it's not going to change my asymptote. So there's the blue one. Okay, how about if we have log base 5 of x plus 5? Belle, can you tell me what happens for this one? Good. Let's graph that one. Translate left 5. So I'm keeping these same original black points. I'm not using the blues at all because that's a different question. If we're going to translate left 5, I'm going to use this side. I'm going to subtract 5. They'll give me negative 4 4/5, negative 4, and 0. And then that will affect the x value. The asymptote. So I'm going to move my asymptote to negative 5. And then I'm going to go negative 4 4/5, negative 1, negative 4, 0, 0, 1. Or we could have just taken the pink graph and translated it to the left. That was not good. Translated it to the left 5 by just counting the points. Okay, so the next one would be translate 8 to the right. How about negative log base 5 of x? Mark, can you help me with negative log base 5 of x? What would that do? So is this a horizontal or a vertical reflection? What was that? It is vertical. So if I'm reflecting up and down, which axis would that go over? That's the x-axis. You said y, didn't you? Yeah. So that should be the x-axis. And so then if it is on the inside, that's going to be a horizontal reflection. That one's going to reflect left to right, and that would be over the y-axis. Sorry, you guys probably are still copying. Did you find some graph paper? Oh, good. I brought some out today, so. Okay. So some examples. We've got f of x equals 3 to the x. So we're going to determine, is this exponential or logarithmic? Caroline, exponential or logarithmic? Okay, so we're just going to do it the way we'd normally do it. I'm going to use, sorry, I have a place for a table and I forgot. I'm going to use negative 1, 0, 1 for my x's. I'm going to plug those in and I'm going to get 1/3, 1, and 3. And my asymptote didn't quite make it into my table, but that's okay. It's the next place right here. That asymptote would be y equals 0. So this has no transformations. The base itself of a 3, that is not a transformation. That's the original question. The B is original question. If there's anything else other than the base and the exponent, then we'll have one. So there's no transformations for that. Now, is it growth or decay? I didn't really talk about that yet. So if you're unsure, we'll be able to tell when we graph it, and then I can talk about why it is growth or decay. Let's go ahead and graph our asymptote at y equals 0. Graph these ordered pairs at -1 1/3, 0, 1, 1, 3. You know, if you were like, I need more ordered pairs, and I plugged in 2, you'd get 9. That one would at least fit on the graph. So left to right, is this graph growing or is it getting smaller? Left to right. This is a growth, right? And the reason why it's growth is because every time I increase the exponent, we're multiplying by another 3. 3 makes things bigger. What kind of number would make things smaller? I couldn't hear. No, I mean like, never mind. So negative, if let's throw out a number there. If I take 3 times -3, it gets smaller, it's -9, times another -3, it's going to be positive 27. Times another -3 would be -81. So that's actually going like up and down and up and down. We're not going to have that situation. So it's not a negative number. You know what it is?
A negative exponent or having a fraction for the number.
We're going to go with having a fraction that is between 0 and 1. So it's not even, you don't even have to say a fraction. Something in between 0 and 1. That's going to multiply and make it smaller. Because if I just say fraction, I could have 5 halves. But 2.5 would make it bigger. So we just want to say between, here, I'll write it at the top. Growth, beep, growth would be if the B value is greater than 1. Decay would be if the B value is between 0 and 1. And then when somebody said negative, that's that a negative base is going to do crazy things. So we're not going to worry about that right now. And then
I was talking about like the x's.
Oh, no, you're right. I'm saying, I think it was like somebody over here said earlier. A negative exponent would do the same thing if the base was a big number, if that makes sense. So, Marie, if I had if I took this one, I had 3 to the negative x, I could rewrite that as 1 over 3 to the x, which would be the same thing as 1/3 to the x. So typically, I'm going to give you this question, not that one. But you're totally right, 100%. And then if you're not sure if it's growth or decay, graph it and look. Okay. The domain. So we're going to do this in interval notation from left to right. What x's get graphed? So this arrow means how far do I go? Forever. To what number? Negative infinity. And then to the right, there's an arrow. Yes? Because we're writing interval notation. All real numbers would be in set notation. Okay, so I'm going to put from negative infinity to positive infinity because it's everything, all real numbers. The range is not all real numbers. That asymptote kind of ruins that. So what is the lowest value that is, what value should we start at? 0. Can it equal 0? It cannot, so we use a parenthesis. And then from there, it's going to keep going up, so we'll have to infinity. Okay? All right, next one. G of x equals 1/2 to the x. So the 1/2 itself is the base, so we have no transformations. Table, I'm going to put in -1, 0, 1. And I will have, what's 1 over 1/2? Bless you. What's 1 over 1/2? No, what's 1 over 1/2? 2. Okay, that's just the reciprocal of a half, 2. And then we'll have 1, and then we'll have 1/2 for the third. Oop, 1/2 for the third one. I wrote a 3. And then y equals 0, because we don't have any transformations. Is this going to be growth or decay? It's going to be decay, and we'll see it as soon as we get it graphed as well. Okay, so -1, 2, 0, 1. 1 is a half. If we needed more ordered pairs, this is an easy one to find more ordered pairs with. Like if I did -2, it would be 4. If I did -3, it would be 8. The domain, how far to the left, how far to the right? It's going to go from -infinity to positive infinity. But the range is going to start at 0 and go above. Okay, question 3. Do we have a transformation? Yes. So what kind of transformation, John? What kind of transformation is this? Zoom in to make my table a little bit easier. Okay, so with the table, I'm going to make a table for e to the x, and then I will do that +2 afterwards. Okay, so e to the x is the natural number, or e is a natural number. It's approximately 2.718. The most accurate we're going to be able to graph is 2.7, okay? Like, you can't really graph that super accurately. X, I'm going to do -1, 0, 1, and then I'll have my y equals 0 for the asymptote. So my when I plug in 0, I get 1. When I plug in 1, I get 2.7-ish. And then the reciprocal of this, and this can be something you just memorize, is about 0.4. It's like 0.36 something maybe. I don't know. But it's about 0.4. What is the reciprocal? .3678794. So about 0.4. So then we'll add 2 to each of those. So I'll get 2.4, 3, and then 4.7. Should I change my asymptote? What do you think? Nairi? Yes, we should. Y equals 2. And it's only because that is a y value, and I can add 2 to 0 and change it. So I'm going to change it. So our asymptote for this one is y equals 2. Do we know if it's growth or decay? Or should we graph? It's growth. Now, if you're not sure because there's an e in there, like look at the table. Are the numbers getting bigger? Yes, it's a growth. So I'll have -1, 2.4. Oh, I've got y equals 2 also. One 3 and 1 4.7. Something doesn't look right to me. It's at 2.4. Oh, I see what doesn't look right. It's this one. 2.4. Still doesn't look right to me.
You're later, so.
Oh, yeah, that should be down further too, huh? There we go. Now it looks much better. Thank you. Okay, the domain, I don't know if you guys are noticing, all of these exponential ones are going to have the same domain every single time. If you didn't notice that, well, I just gave away a secret. Our range, though, isn't always the same. So what's our range going to be for this one? Lydia, can you help me with the range? Yep, that is correct. You're going to start with that asymptote. Marie, how you doing? You hanging on with the graphing? Okay. It's fun. All right, how about number 4? Do we have any transformations? Yeah? Translate. Left 3 units. Let's make a table. Nah. So I'm going to use -1, 0, 1, y equals 0. When I do -1, that reciprocates 1/3. So I get 3. 1, and then when I put 1 in, I get a third. We're going to translate left. So on my x side, I'm going to subtract 3. Does that change my asymptote? Caitlin, do you know why it doesn't?
Because you have to move it to the left.
And just when I look up here, it's on the y side, and I don't change the y numbers with my x numbers, right? Okay. Does anybody know if it's growth or decay? It is decay. Decay. Was that what he said? Kind of sounded like it. Just me? Okay. So -4, 3. -3, 1. -2, 1/3. Domain's going to be -infinity to +infinity. And Nick, can you help me with the range? 0 to infinity. Okay, I want to stop talking for a moment, and I want you to try number 5. We haven't done one like that yet. Okay, let's see if you can figure it out. I want you to try number 5. If you felt like that was easy, try number 6. If you got questions, questions, I'm walking around looking over your shoulders. Is it too easy for you? Too easy to yell out. So your point that you grabbed was like constantly that. And I think you just, no, those were fine. Those were fine actually. It was just the first point that you had written down. Look at your second point, your third one. Oh, I just wrote the equation here. I mean, I could have written 5 to the x right there instead of y. Either's fine. Yeah. I was just writing like the, what's it called? Parent function there. Okay, so I did number 5 up here. I'm going to do number 6. I didn't do number 5 with explaining. A lot of you walked around and you had no problems with it. If you do have questions, make sure you ask. So let me go through number 6. And if you're like, this is too easy, you can work ahead if you'd like. I'm going to go over the next one's logarithmic, isn't it? Yeah, next one's logarithmic. So, all right, transformation. There's going to be a reflect in the y-axis for this one. And so my reflection is going to multiply by -1 on the x side, which does not change my asymptote. So when I graph this one, because of that reflection in the y-axis, this one actually becomes decay. And everything else should be about the same that it's been. All right, let's move on to logarithms. So I look at f of x equals log x. Transformations, none. So this is how I do my logarithms. I think about the base being 10, and I think about what my 10 to the x table would look like. That would be like -1, 0, 1, which would be 1/10, 1/10. I think about that, and then I switch the x and the y's. So 1/10, 1/10. I forgot part of my table. -1, 0, 1. And then I have, instead of y equals 0, I have my x equals 0 on the table. So usually you will see my work looking like this off to the side, because that's not part of the problem. That's just how I'm figuring out the original points for the logarithm. I just find out the exponential, the inverse first, and then I flip them. Okay, and there's no transformations for this, so we've got x equals 0 for our asymptote. And I go to 1/10, -1. I go to 1, 0, and to 10, 1. The domain from left to right is not everything now. So the domain and the range switch from what they were when we did exponential. The domain is now from 0 to infinity. Oops. And the range is down to up infinite, negative infinity to positive infinity. So those totally switch from the exponentials as well, because those are x and y's too. Okay, number 8. So when I go to do logarithmic, first of all, there's no transformations for this one. I first think about if it were 1/3 to the x, what would that look like? So that would be 1/3 to the x. I'm going to take that information and make my table to just flip the x and y's. Including my asymptote that now becomes x equals 0. Yes, Chris.
Take like the base of the logarithm.
Yep.
You do like what it would be as an exponent.
Yep. So I'm not actually doing logarithms. I'm just doing exponentials and flipping. That's what I'm doing. Okay, so I've got 3, -1, 1, 0, and then 1/3, 1. Now this one, look, we hadn't, we only graphed the one logarithm, and then the ones on that first page, they all looked like they were going uphill. This one kind of looks like it's going downhill, and that's because the base is a fraction. So where the base was a fraction when we did exponentials, it was a decay. That's why it looks like it's going downhill when the base is a fraction for logarithms. The domain is going to, for this one, still start at 0, go to infinity, and the range is going to go from negative infinity to positive infinity. All right, so the next one has some transformations. And I'm just going to throw a hard one out right now. This is a hard one. It's not hard, but the hardest kind. Transformations. What transformations do we have? Okay, so you're partially correct. It is a reflection in the y-axis. When we did these transformations a while ago, especially when we did them with trigonometry, you cannot have this. Back when we were calling it the B value, but I don't want to call it the B value because now a B means something different here. But you can't have a stretch or shrink or reflection in the same parentheses with the translate. When it's horizontal, they need to be separated. They can't be in the same room. They don't like each other. They need to be separated. Do you remember how I separate these guys? I got to factor it out. So I'm going to have log base 2, and then I'm going to have negative, and then I'm going to have x minus 3, close parenthesis, close parenthesis. So I have to separate those guys. So this is actually a translate right 3 units. If you don't believe me, graph it, you'll see it. Like on your calculator, I mean graph or Desmos. Okay, so I would start by thinking about the 2 to the x. That's where I'm going to start, thinking about the 2 to the x. Even though there's transformations, I'm still thinking about the 2 to the x. Okay, then when I write my table for the logarithm, I switch my x and my y's from my 2 to the x. And switch my asymptote. And I'm going to do the transformations on the switched points. I don't use the transformations on the inverse at all. Okay, I use them just on the switched points because those transformations are on the logarithm equation. So we have a transformation, a reflection in the y-axis. So we multiply our x values by -1. So I'll get -0.5, -1, -2. But what happens when I multiply x equals 0 by -1? Yeah, it's still x equals 0. 0 times anything is still 0. Okay, and then I have translate, which direction was it? To the right? Yeah, to the right, 3 units. And remember, we always multiply before we add or subtract. So now I will add my 3. So it'll be 2.5, 2, and 1. Will that change my asymptote? So x equals 3. So I graph the outside x's and y's. So I'll go to, well, x equals 3 will be my asymptote. And then 2.5, -1, 2, 0, 1, 1. And sometimes people have trouble graphing this one. If you did have trouble, is there anything stopping me from finding more points? There's nothing stopping me. So I'm going to assume you don't have trouble, but I am going to pretend I did have trouble. And I'm like, I don't really know what to do. What if I just pick another number? And I want it to go this, like to the left more. So what's that last one? That one was this one. So maybe I'll pick 2 for the original, which would be 4. So that would put a 4 here and a 2 here, which would make this a -4, which would make that a 1. So 1, 2. No, that's not right. A -1, sorry. Only if I could do math, right? -1, 2. So now I might have a better idea of what the graph is actually doing. It does have to get closer to the asymptote. So those 3 red points are getting closer to the asymptote. So it's going to go down. And then in this direction, it's going to raise back up to the left. So our domain is going to go from -infinity to the asymptote 3, but it won't equal it. And then our range will be everything, up to down, down to up, -infinity to +infinity. So that's probably the hardest kind that you would have. Oops. All right, let's try one more together. Number 10, transformations. Transformations for number 10. Marie, can you help me with the transformations? Either of them? One of them? Two of them?
It's going down 5.
Okay, translate.
It's going to reflect over the x-axis.
That is correct. Okay, so before I make my table, I'm going to go off to the side and I'm going to make my table for 4 to the x. So I have my exponential. This is not exponential, it's logarithmic, so I'm going to switch those. Didn't really leave a lot of space for my table in here. 1/4 1, 1 0, 4 1, x equals 0. Okay, so we have a reflect in the x-axis, which we multiply the y's by -1. Oh no, one of them's wrong. This one here. Okay, so when I multiply by -1, does that change my asymptote? Does not. So then I'm going to subtract 5 from each of those. And we can graph. (1/4) -4. 1 -5. And then 4 is -6. How confident do you guys feel? And you look at these last two, do you feel confident you could do them both? So should we try the last one? Let's try the last one. Okay. So I'm going to skip number 11. All right, so I see the ln, and I should know that is log base e. So I'm going to make an exponential. I'll do the transformations in a moment. I'm going to make an exponential that has e to the x in it. So 0 is 1. E is about 2.718. I'm just going to write 2.7 because that's as close as you're going to get. And then memorize that to the -1 is 0.4. Okay, just get that memorized. I mean, if you forget you have a calculator, you could do e to the -1 on the calculator. So the transformations, this is inside of the parentheses. So is that going to be horizontal or vertical? It's inside of the parentheses. Horizontal, sideways, yes. So this is going to be a translate. 4 units, Sarah Penny, 4 units which way? Left. Good. And I'll go ahead and switch my original table. I'm going to switch those. So I'll have 0.4, then -1. And I'll have x equals 0. And then translating 4 to the left, that will subtract 4. And that will change my asymptote to be x equals -4. So I'll go on my graph and I'll go to x equals -4 and graph that baby. Go to negative 3.6, -1. -3, 0. -1.3 if I did my math correct. 1. So my domain's going to start at -4 and go to infinity, and then the range -infinity to positive infinity. Okay, and that's all we're doing today. It took a while, but that's just because I was very thorough. Thorough? Is that thorough? I don't know what happened there. All right.